Chapter 7. Continuous Probability Distributions. Recall in Chapter 6, Discrete Probability Distributions, we try to find out the probability of a random variables to be a certain value, because that is a discrete probability distribution. And in this chapter, we try to find out the continuous probability distributions. Means when the random variable is a continuous random variable, and we try to find out the probability of the random variable follow into a certain range, or the probability of the values follow into a certain range. There are several continuous probability distribution. In this chapter, we mainly focus on the normal probability distribution. What is normal probability distribution? First, it is a bell-shaped and has a single peak at the center of the distribution. It is symmetrical about the mean. It is asymptotic. What that means the curve gets closer and closer to the x-axis, but it never actually touches it. To put it another way, the tails of the curve extend indefinitely in both directions. The location of a normal distribution is determined by the mean. The dispersion or spread of the distribution is determined by the standard deviation sigma. The arithmetic mean, median, and mode are equal. The total area, this one is very, very important, okay? The total area under the curve is 1. What that means the probability of a certain value follow in under the whole curve, the probability of that is 1. Means, certainly happen. Half the area under the normal curve is to the right of its center point, to the right of its mean number, and the other half to the left of the mean. So what is this normal probability distribution look like? Let's check this graph. Okay, this is normal probability distribution. It's symmetrical. It has two halves identical, centered at the mean, and the mean, median, and mode are equal. And the two tails get closer and closer to the x-axis, but never touch it. So the curve, theoretically, the curve extended to infinite. There are a family of a normal distribution. For this one, these three normal distributions has the same mean number, okay, but has a different standard deviation. So when standard deviation is smaller, you can tell the normal distribution is narrow, more narrow and taller. When the standard deviation is larger, then the normal distribution is flatter, means the data of this distribution more spread out. For this one, it means different normal distribution has a different mean number and also has a different standard deviation. So they have the different shapes. For this one is all these normal distributions which look exactly like each other because it has the same standard deviation. The spread out is same. That's why they have the same shape, but they have the different mean number. Okay, the mean of this one is greater than the mean of this one, and the mean of this one is greater than these two. So In the beginning, I talked about the purpose of this chapter is we try to find out the probability of the distribution. What does that mean? Means we want to know the probability of the value follow into certain range. For example, for this red line, for this red normal distribution, and we want to know the probability of the variables fall into the range between the 13 and 19.5. We want to find out that, the probability. And the formula for it is very, very, very complicated. Luckily, we don't need that formula to do that calculation. So how do we find out the probability for that? For the the random variables falling into the certain range. We use standard normal probability distribution. Standard normal distribution is a normal distribution with a mean of 0 and a standard deviation of 1. So for any normal probability distribution with mean of 0 and a standard deviation of 1, we call it standard normal probability distribution. It is also called the Z distribution. So a Z value is a shunt distance between a selected value designated x and the population mean mu divided by the population standard deviation sigma. The formula is like this: Z value equal to x minus mu over sigma. So once we find out the Z value of a certain value, we can convert our normal distribution, any kind of normal distribution, into a standard normal probability distribution. Once we convert the normal probability distribution into a standard normal probability distribution, we can use a table. We call that a Z table, help us find out the probability of that value falling into certain range. How do we understand that? Let's check some examples out. For example, for this normal probability distribution, we try to find out the probability of value fall into the range between the mean of this distribution 283 and 285.4. We want to find out the probability of value falling into this range. The first step, we convert this normal distribution into the standard normal distribution. How do we do that? We try to find out the Z value for these two numbers. Okay, so for this number, the mean number, we use the formula for the Z value. The formula for the Z value is, the any value minus mean number and over standard deviation. So if we use 283 divided by mean number is 283, we get a 0. 0 divided by standard deviation, then we get a 0. So for the mean number, the Z value is 0. Okay, how about this number, 285.4? For 285.4, the Z value for it is, we use 285.4 minus mean number 283. Then we get a 2.4 divided by the standard deviation. Okay, the standard deviation actually in our textbook it is in our textbook. Okay, so I didn't show in the slides. So it is 1.6, and divided by 1.6 we get the 1.5. So 1.5 is the Z value for this number. Once we find out the z-value for this number, we can use the z-table. Okay, I will post the z-table on Moodle, so you can use that to check. How do we use the z-table? So to find out the probability of the value falling into this range is actually we try to find out the area under the curve. And we already know the z-value of 1.5. So first, go to the column handed by the z. Go all the way down to 1.5. And then move horizontally to the column headed by the 0.00 because it's 1.50. So we find out the 1.5, then we need to find out this 0 is here. Okay, 1.500. So move horizontally to the column headed by 0.00. Then we get the cross value is 0.4332. So this 0.4332 is the area under this curve. It also means the probability is 0.4332, 43.32% probability that the value gonna follow into this range. Okay, let's check this out. Normal distribution examples. The weekly incomes of a shift foreman in the glass industry follow the normal probability distribution, with a mean of 1,000 and a standard deviation of 100. So now we know the mean is 1,000 and the standard deviation is 100. What is the z-value for the income? Let's call it x of a foreman who earns 1,100 per week for a foreman who earns 900 per week. So how do you find out the z-value for that? For the income equal to the 1,100, z-value equal to x minus mu over sigma equal to 1,100, that's our selected value, minus 1,000, then over 100 equal to 1. So z-value for the 1,100 is 1. For x equal to 900, z-value equal to x minus mu over sigma equal to 900 minus 1,000 over 100. We got -1. So this example actually reveals a certain we call empirical rule. So about 68% of the area under the normal curve is within one standard deviation of the mean. What does that mean? Means around the mean number under the normal distribution curve, the area is 68%. Around the mean number, 95% is under the range with 2 standard deviation of the mean from the mean. And practically almost all is within 3 standard deviation of the mean. Okay, let's check more examples. For the example for the empirical rule, as a part of its quality assurance program, the Autolite battery companies conduct tests on the battery life for particular D-cell alkaline battery. The mean life is 19 hours. The useful life of the battery follows a normal distribution with a standard deviation of 1.2 hours. Answer the following questions. About 68% of the battery is filled between what two values? About 95% of the battery is filled between what two values? Virtually all of the battery is filled between what two values? See, now you know how we use the normal probability distribution. We try to find out the probability of the certain value follow into the certain range. Here, is let us find out the range. We can use the result of the empirical rule to answer these questions. About 68% of the batteries will fill between 17.8 and 20.2 hours. How do we find out that? We use the mean number 19 plus and minus 1 standard deviation. About 95% of the battery will fill between 16.6 and 21.4 hours. We found that by the mean number 19 hours plus or minus 2 standard deviations. Virtually all filled between 15.4 and 22.6 hours. We found that by using mean number 19 hours plus or minus 3 standard deviations. Okay, now let's use our normal distributions to find out the probabilities. In early example, we reported that the mean weekly income of shift foreman in the glass industry is normally distributed with a mean of 1,000 and a standard deviation of 100. What is the likelihood of selecting a foreman whose weekly income is between 1,000 and 1,100? So, what's the first step? First step, we need to find out the z-value for these two numbers. For the 1,000 is also the mean. The value for the mean number is 0. And for the 1,100, the z-value is 1. So we can easily find out based on the empirical rule, can find out the 1 standard deviation away from the 0 is half 68%. Okay, for another example, still using the same question regarding the weekly income of shift foreman in the glass industry. The distribution of weekly incomes follows a normal probability distribution with a mean of 1,000 and a standard deviation of 100. What is the probability of selecting a shift foreman in the glass industry whose income is between 790 and 1,000? So again, the first step, find out the z-value for these two numbers. So z-value for the 790, z-value equal to 790 minus 1,000. 1,000 is a mean number over standard deviation 100. We get a negative 2.1. And for the x equal to 1,000, 1,000 is also the mean number, right? So the 1,000 minus 1,000 over 100, we get the 0. So now we find out the z-value for the 790 is negative 2.1. Using the same method, in the z-table, we can find out the area for the z of the 2.1 is 0.4821. So the probability of selecting foreman in the glass industry whose income is between 790 and 1,000 is 48.21%. How about less than 790? So if we already know this red area is 0.4821, how do we find out the less than 790? That means we need to find out the area, this purple area. Remember, the whole area under the curve is 1, and the normal probability distribution is symmetric. So this half will be 0.5. We just use from the 0.5 deduct the 0.4821, we can get the purple area is 0.01979. Okay, so now you find out if you want to find the area less than certain values, you first convert that value into the z-value, and then use z-value and z-table find out the area of this, and then use the 0.5, that's 50%, minus it, you can get this area. the area less than that certain value. Next, let's see what else. Okay, how about we want to find out the area between these two numbers? Means that these two value is on the each side of the mean value. See, how about what the probability of selecting a shifted foreman in the glass industry whose income is between 840 and 1200? So we find out first z value for 840. We find out the z value for 1200. Z value for 840 is negative 1.6. Z value for the 1200 is 2. We use the z table, find out the area for the z value of negative 1.6 is 0.4452, and the area corresponding to the z value of 2 is 0.4772. So the probability of selected foreman in the glass industry whose income is between 840 and 1200 is 0.4452 plus 0.4772 together. How about between the 1150 and 1250? Again, find out the z value for 1150, that's 1.5, and the z value for the 1250, that's 2.5. So we find out the area for the z value 2.5, and then minus the area for the 1.5, this part, you can get the 0.0606. For the let me check this one. Okay, ignore this slide and the slide behind. For these two slides, we will not cover for this course. Okay, so if you have any questions, please send me email. I think the hard part is for the the beginning learner. The hard part is using this z table. So just remember, for the normal probability distribution, we always convert the normal probability distribution into the standard normal distribution. How do we do that? Is turn this value into the z value within the z value formulas, x minus mu over sigma. Once you find out the z value, then using z table, okay, in the column headed by z, you can find out the first two digits of the z value, and for the third one, you just move horizontally to the column headed by that third digit. You will find the area. That number is the area under the curve. That number is also the probability that the random variables fall into the certain range. In this case, is the range of the 283 to 285.4. Okay, so again, if you have any questions, please do not hesitate to contact with me. This part is very, very important. If you don't get this chapter, it will be very, very hard to understand the following chapters.